Welcome to the Wandering Neuron, a quiet place where your mind can travel across the universe while your body rests deeply here on Earth. Tonight, we drift together into one of the most fascinating questions in modern physics, a question that has puzzled scientists, philosophers, and dreamers for centuries. Is the speed of light really the fastest thing in the universe? Or could there be something even quicker, something hidden beyond the limits of what we understand? As you listen, allow your breath to soften. Allow your thoughts to slow down. And let your curiosity remain awake, even as the rest of you sinks gently toward sleep. The universe is vast and quiet, and tonight it will unfold for you one layer at a time. Light travels at 299,792 kilometers per second, fast enough to circle Earth more than 7 times in a single heartbeat. For more than a century, this number has been treated as something sacred, a constant woven into the fabric of physics itself. Albert Einstein proposed that nothing with mass could ever cross this cosmic speed limit. It wasn't just a rule, it was the rule built directly into the structure of space and time. But tonight, we aren't here to memorize facts. We're here to gently explore them, to let their meaning wash over your thoughts like waves on a distant shore. Why the speed of light matters. The speed of light is not just about brightness. It's the speed at which information can travel, the maximum rate at which cause can affect effect. It shapes everything: time, movement, energy, even the way you experience the present moment. Imagine holding a small flashlight in your hand. The moment you switch it on, photons rush forward instantly, but not infinitely fast. They have a limit, a boundary, and that boundary shapes the universe itself. A gentle hook. But what if light is not telling us the full story? What if the universe still holds secrets, hidden behind this shimmering curtain of speed? Let that question settle softly in your mind as we drift even deeper. At first, physics tells us nothing goes faster than light. But then, space itself quietly whispers, "I do." This is one of the most beautiful contradictions in cosmology, a contradiction that isn't truly a contradiction at all, because the rule isn't about space expanding, it's about objects moving through space. The expanding universe. The universe is growing. Every second, space stretches like a calm, slow breath. Every galaxy drifting farther away from every other galaxy. Not because they're traveling through space at impossible speeds, but because space itself is expanding. When astronomers look at very distant galaxies, they see them moving away faster than the speed of light. And that's allowed, perfectly allowed, because the galaxies aren't breaking the speed limit. The cosmic fabric beneath them is doing the stretching. Why this matters for our question. If space can outrun light, then perhaps the true limit is not as fixed as we once believed. Maybe the concept of fastest depends on what we mean by speed and what we mean by motion. Is the expansion of space a kind of speed? Or is it something deeper, something the mind can barely grasp? As you rest, let yourself imagine the universe breathing, quietly stretching, gently carrying galaxies away from one another like lanterns floating on a dark, endless ocean. Hook to keep the mind curiously awake. If space can outrun light, what about the things hidden inside space? Particles, forces, quantum mysteries. Could one of those be even faster? We continue, slowly, softly, into the deeper layers. Now we step into a realm that isn't proven, but isn't impossible either. A realm of theoretical particles that only exist if they can travel faster than light. They are called tachyons, created from the Greek word tachys, meaning swift, swifter than anything else the universe has ever offered. In physics, tachyons are hypothetical particles that can only exist if they are always moving faster than light. If they ever slowed down, if they ever reached the speed of light, they would cease to exist. It's a strange concept, beautifully strange, like raindrops that disappear if they fall too slowly. Even if tachyons have never been seen, their idea helps physicists test the boundaries of Einstein's theories. Tachyons remind us that our understanding of the universe may not be complete, that there could be layers hidden beneath layers, each more mysterious than the last.
Imagine tiny particles racing across the universe, so fast that light itself seems slow to them, like a feather drifting behind a soaring bird. They would not carry familiar forms of energy. They would not obey familiar rules. They would be creatures of pure theory, whispers at the edge of what physics allows. If tachyons might exist, then maybe the cosmic speed limit is not truly absolute. Maybe it's more like a suggestion, a structure that holds for most things, but not for all. As your body grows heavier and your eyes grow softer, let your mind hold on to that gentle, shimmering possibility. There is a strange and beautiful property in quantum physics, something so mysterious that even Einstein called it spooky action at a distance. Quantum entanglement, a quiet, invisible thread that links two particles together no matter how far apart they drift across the universe. Imagine two tiny particles born together, like twins sharing a secret language that no one else can speak. You send one to the other side of the galaxy, and you keep the other here on Earth. If you change one, the other one changes too. Instantly. No delay, no travel time, no waiting for light to make the journey. To the human mind, it feels impossible. How can information move instantly across such enormous distances? How can two particles behave like a single entity, even when light, the fastest messenger we know, would take billions of years to travel between them? Physicists say this is not information in the usual sense, not a signal moving faster than light. Instead, it is a deep connection built into the very state of the particles themselves. But for a mind drifting toward rest, it raises a soft, beautiful possibility. Maybe speed is not the only thing that matters. Maybe the universe has shortcuts, paths hidden beneath the surface, threads connecting distant places without crossing the space in between. As you relax deeper, you might imagine entanglement as tiny lanterns lighting up at the exact same moment, no matter how far apart they float. An instant whisper between stars. A reminder that the universe may be far more connected than it appears. And if something can connect instantly, without waiting for light, then perhaps the speed of light is not the ultimate ruler after all. Let that thought linger softly as we gently drift forward. There was a moment, long before galaxies formed, long before planets cooled, long before stars even dreamed of burning. A moment just after the birth of the universe itself. In this tiny sliver of time, a fraction of a second, the universe expanded faster than the speed of light. Not once, not briefly, but explosively. A silent, unstoppable burst. This era is called inflation, an era when space didn't simply stretch, it surged outward with unimaginable speed, doubling again and again so quickly that the entire observable universe grew from something smaller than a grain of sand to something larger than all the galaxies we can see today. Nothing inside space traveled faster than light, but space itself did. It did so naturally, effortlessly, as if the cosmos was taking its first deep breath, a breath so powerful that even light could not keep up. When we look at the night sky, we're not just seeing stars and galaxies. We're seeing the aftermath of a moment when the universe outran everything, including light. This early burst explains why distant regions of the universe look similar, why space feels smooth and balanced, why the cosmic background radiation is almost the same temperature everywhere. Because when everything was packed together, all regions shared the same conditions. Then, in an instant, they were flung apart faster than any signal could travel. And so tonight, as you rest, you can imagine the universe stretching around you, not slowly, not gently, but with a speed that defies imagination. Not breaking the laws of physics, but showing us that the laws are deeper, more flexible, more mysterious than they appear. If the universe once expanded faster than light, then maybe the question isn't what is the fastest thing, but what does speed even mean when the universe itself is in motion? Let that thought float softly beside you as we continue deeper into the cosmic night. Now we drift into one of the most imaginative, most mesmerizing ideas in all of physics: wormholes, gateways, silent bridges connecting two distant places in space, or perhaps even two distant moments in time. Instead of traveling through space at any speed, slow, fast, or even faster than light, you take a shortcut, a tunnel, a folded path. Imagine holding a piece of paper. You mark two dots on opposite corners. If you travel across the surface, the journey is long. But if you fold the paper, the dots touch. In that moment, distance becomes an illusion. And so does speed. This is what a wormhole would be. Not moving faster than light, but removing the space that light would have needed to travel through. If such tunnels exist, even if they flicker open for the smallest fraction of a second, they would allow something to traverse the universe without ever outrunning light, simply by skipping the distance entirely. To the traveler, it might feel instantaneous, a step forward through a doorway, a shift from one star system to another. Physicists don't know if wormholes are stable, or safe, or even real. But the mathematics allows them. The fabric of space-time does not forbid them. And in the quiet corners of the universe, where gravity bends and stretches reality, there may be pathways, hidden like secret streams running beneath a forest floor. As you breathe slowly, you might imagine drifting near one of these cosmic tunnels, a gentle swirl of starlight around the opening, the calm hum of gravity curving space like a soft cradle. No rush, no noise, just possibility. A reminder that the universe is not only vast, but clever. It may offer shortcuts instead of speed, whispers instead of force, doors instead of distances. And if such doors exist, then perhaps the speed of light is not a boundary, but simply one of many paths the universe allows. Let your mind rest there for a moment, floating peacefully near the edge of wonder. As your body continues to soften and your breath becomes slower and quieter, we drift into the next most profound idea in all of science: the geometry of space-time itself. When Einstein introduced the world to the concept of relativity, he wasn't just suggesting new mathematical rules. He was describing a universe where space and time are not separate things, but part of a single flexible fabric, able to bend, stretch, tilt, ripple, and curve. This fabric is not visible. You cannot hold it or touch it. But everything, planets, light, galaxies, even your own heartbeat, moves upon it. And the shape of this fabric determines how fast things can travel. We often imagine space as an empty stage where events happen. But in truth, space is an active participant. When a massive object sits in space-time, like a star, it presses down gently on the fabric, creating a curve. Light passing near it bends. Time runs just a little slower. Imagine the fabric of reality like a vast, soft blanket, and every star and planet a gentle weight resting upon it. The blanket curves around them, guiding everything that moves nearby. But here is the deeper mystery. This fabric can curve so sharply, so intensely, that the normal rules of distance and speed begin to dissolve. Near a black hole, time slows to such an extent that a single moment for the falling observer may stretch into hours or years for someone far away. And inside certain theoretical shapes, tiny regions known as closed time-like curves, the geometry becomes so twisted that a path through space might loop back on itself through time. In these extreme regions, the speed of light remains constant, but the way space is shaped changes what speed actually means. It's like walking from one point to another. On flat ground, the path is long. But if the ground folds or curves, the same step might take you somewhere completely different. So as you rest, you can imagine the universe not as a rigid structure, but as a living, moving landscape. A shifting terrain where light speed is constant, but the distances it must travel are not fixed at all. This idea that space-time can manipulate what speed means opens the door to profound possibilities. possibilities that take us even deeper into the heart of what fastest truly means. And so we continue, drifting softly into the next layer of wonder. In the quiet depths of the subatomic world, beyond atoms, beyond protons and electrons, there exists a class of particles so subtle, so ghostly, that trillions of them pass through your body every second without leaving a trace. Neutrinos. For decades, scientists believed these particles had no mass. They moved through matter as easily as light gliding across a glass. They barely interacted with anything at all. When neutrinos were first discovered traveling from distant cosmic explosions, their speed approached and once seemed to even exceed the speed of light. It caused a storm in the scientific community. Could neutrinos be traveling faster than light? Had the universal speed limit been broken? Was Einstein wrong? Later experiments corrected the measurement errors. Neutrinos were not faster than light, but they were close. So close, so quietly swift, that they still whisper a beautiful possibility. There may be particles we have not yet discovered. Particles even stranger, even lighter, even more elusive than neutrinos. Particles that might not obey the rules that light obeys. In physics, we explore something called the hidden sector, a theoretical region of the universe made of particles that interact so weakly with ordinary matter that we cannot detect them directly. These particles might be faster than light, unaffected by electromagnetic forces, capable of moving through dimensions we cannot see, messengers of unknown cosmic symmetries. In some theories, these hidden sector particles drift effortlessly through the universe, like ripples on a pond that humans cannot perceive. Some physicists believe these particles could help explain dark matter, a mysterious substance making up most of the universe's mass, yet remaining invisible. If an entire population of unknown particles exists, traveling in ways we cannot observe, moving at speeds that do not affect the world we see, then the speed of light might not be nothing more than the limit for our kind of matter in our corner of reality. Other forms of matter, living quietly in the dark, could follow entirely different rules. As you breathe slowly, imagine these particles drifting through space like silent streams of starlight, carrying secrets we have not yet learned to hear. And now, we move deeper still, into the fabric beneath the fabric. There is a gentle, breathtaking possibility in modern physics that our universe may not be the only universe, that reality may be layered, stacked, branching, spreading outward like an infinite forest of cosmic possibilities. Some theories suggest that space has more than 3 dimensions, but the extra ones are curled so tightly that we cannot perceive them, like tiny pathways folded within pathways, hidden in the smallest scales of reality. If these dimensions exist, and if some particles or forces can travel through them, they might bypass the limits we observe. A particle moving through a higher dimension might appear to us as if it moved faster than light, even if it followed the rules of its own dimension perfectly. Imagine a creature walking through a long hallway. It must travel slowly from one end to the other. But if the creature could step outside the hallway, into a hidden space, a space you cannot see, it might reappear instantly at the other end, without crossing the distance in between. To you, it would seem like it teleported. To the creature, it simply took a shortcut that you did not know existed. Some physicists believe gravity itself may be leaking into a higher dimension, which is why it feels weaker than the other forces of nature. If gravity can move through extra dimensions, perhaps other forms of energy can as well. Perhaps speed is not the barrier we imagine it to be. Perhaps the universe is a vast structure of interwoven layers, folds, and hidden corridors, and light is simply following the rules of the layer we live in. As you rest deeper, you might picture reality as a soft, glowing tapestry. Threads of different colors, different dimensions, all weaving through one another in exquisite silence. Some threads follow the pathways we know. Some slip through layers we cannot see. Some pass through the entire tapestry in ways that make our definition of speed feel incomplete. And in that gentle mystery, you find a sense of wonder that asks nothing of you except to drift a little deeper into the quiet.
There is a quiet force woven into the universe, a force that does not shine, does not pull, does not push in any familiar way. It does not behave like gravity, which gathers galaxies together, or like electromagnetism, which binds atoms and light. Instead, this force does something stranger. It causes the universe to speed up, to expand more quickly as time goes on. Scientists call it dark energy, but the name is only a placeholder. What it truly is, no one knows. Imagine a calm ocean stretching in all directions. At first, the waves drift outward slowly, but with each passing moment, they begin to move faster, and faster still, as though some invisible breeze is urging them outward. Dark energy is that invisible breeze. Silent, steady, mysterious. And as the universe expands faster, we learn something profound. Even the speed of light cannot cross the growing distance between certain distant galaxies. Not because light is too slow, but because the ocean of space is stretching beneath it, stretching faster than light can swim. This creates a strange horizon, a boundary in the universe beyond which we will never see. Not because the light won't reach us, but because space is expanding too quickly for the light to ever bridge the widening gap. This means there are regions of the universe already lost to us forever. Parts we will never witness, never study, never know. And in those unreachable realms, space may stretch faster, matter may behave differently, and the cosmic rules we know may not apply at all. As your breath settles into a soft, natural rhythm, you can imagine the universe as a vast, tranquil tide, carrying distant galaxies away on an accelerating current that no light can outrun. Dark energy reminds us that the universe is not static, not predictable, not confined to the boundaries that seem absolute. Even speed itself becomes a flexible idea in the presence of such a force. And so we drift deeper into the layers beneath that mystery. In the early moments after the universe was born, when everything was unimaginably hot and dense, Space-time may have formed tiny cracks, minute imperfections in the fabric of reality itself. These theoretical threads are called cosmic strings, slender lines of immense energy, perhaps as thin as an atom, but longer than galaxies, stretching across the universe like quiet, ancient scars left over from creation. If cosmic strings exist, they would be incredibly powerful, far denser than a mountain packed into a single thread. Taut, unbreakable, timeless. And they might vibrate. Just as a plucked guitar string sends ripples of sound through the air, a cosmic string vibrating would send ripples through space-time itself. These ripples would travel as gravitational waves, waves that move at the speed of light, yet originate from objects so exotic and so energetic that their influence might reach across entire eras of cosmic history. Some theories suggest that two cosmic strings could cross paths and snap together, releasing bursts of gravitational energy so powerful that they briefly distort space in ways we can barely imagine. In those distortions, the very measurement of distance shifts and twists. And when distance can bend, speed becomes a softer concept. Because speed only makes sense when space remains still. When space itself is alive and moving, the idea of fastest begins to melt away, like mist dissolving in sunlight. Cosmic strings, if they exist, are reminders that the universe may still hold relics of a time when the laws of physics were not what they are today. A time when energy moved with an intensity beyond our understanding, when space was young and wild, and when the meaning of speed may have been entirely different. As you drift deeper, you can imagine these strings as silent threads cutting across the cosmos, vibrating in rhythms older than galaxies, carrying secrets from the first heartbeat of the universe. Now we drift to the smallest scale imaginable, smaller than atoms, smaller than particles, to the very fabric of emptiness itself. What we call empty space is not truly empty. At the quantum level, the vacuum is alive, a restless sea of energy, where particles flicker into existence for the briefest moment, and then vanish again, before the universe even notices. These are virtual particles, constantly appearing and disappearing, borrowing energy from the vacuum, then giving it back in a cosmic rhythm so subtle and constant that it forms the foundation of everything else. In this sea of quantum fluctuations, speed becomes almost meaningless. A particle might appear here and disappear there without crossing the distance between. Not movement, not travel. Just a shift of existence from one place to another. Some theories suggest that on this quantum level, information might propagate in ways that defy classical limits, moving through the vacuum in patterns we cannot yet measure. Like whispers beneath the surface of reality, ripples so delicate that even our best instruments can barely sense their presence. The quantum vacuum is also thought to be connected to the energy driving the expansion of the universe,
linking the smallest scales to the largest. This means the same field that causes particles to flicker in and out of existence may also be responsible for the accelerating expansion of the cosmos. Tiny fluctuations and the fate of galaxies woven together. And in this dance beneath reality, time, distance, and speed lose their familiar shapes. Movement becomes probability. Space becomes potential. Speed becomes a pattern rather than a limit. As your breathing becomes softer, as your mind begins to float, you can imagine these quantum flickers as tiny stars forming and dissolving in the darkness beneath everything. A silent, invisible heartbeat carrying the pulse of the universe. As you settle even deeper into this soft silence, imagine the universe not as a fixed stage, but as a living, breathing fabric that stretches, folds, and reshapes itself over billions of years. When we think about speed in everyday life, we imagine moving through space. But in the universe, sometimes space itself moves. And this is one of the quiet loopholes in the speed of light story. Light has a limit, but space does not. In the very early universe, during the period called cosmic inflation, space expanded faster than light could ever hope to travel. Galaxies didn't zoom away, the space between them swelled, like ripples expanding across a calm pond. It means that the light we see today from distant galaxies comes from places that were once much closer, but drifted away on the expanding tide of space-time itself. When space stretches faster than light can cross it, distance becomes a suggestion, and the universe opens its horizons beyond anything our senses can grasp. Even tonight, galaxies at the edge of our sight are moving away faster than light, not because they're breaking the rules, but because the rules themselves are made of stretching space-time.
If space can expand faster than the light, then perhaps there are other quiet, subtle ways for the universe to slip around cosmic speed limits. One of these ideas lives in the mathematics of wormholes. Not the cinematic, stormy kind, but the gentle, hypothetical tunnels predicted by Einstein's general relativity. A wormhole doesn't make you travel faster than light, it simply makes the distance shorter. Instead of crossing the full length of the galaxy, you fold space-time, like touching 2 points on a paper. The travel feels instant, but you never exceed the cosmic speed limit. You simply bypass it. Physicists still don't know if stable, traversable wormholes can exist, but the equations suggest they're not impossible. They whisper a possibility, a soft maybe, tucked into the mathematical fabric of the cosmos. And even if wormholes remain theoretical, their existence reminds us of a deeper truth. Speed is not always about motion. Sometimes it's about geometry. And the universe, in all its quiet strangeness, might be shaped in ways we've only begun to imagine. There's another subtle place where the universe bends the idea of speed, inside the quantum world, where particles behave less like objects and more like probabilities. In this tiny realm, something called quantum entanglement links particles across immense distances. When one particle changes, the other responds instantly, as if the universe forgot to load the distance between them. Einstein famously called it spooky action at a distance because it seemed to happen faster than light, too fast to make sense in a classical physical world. But quantum entanglement doesn't carry information the way light does. It doesn't send a message. It simply reveals a deep connection woven into the structure of reality. It's like two reflections in a mirror. What happens to one instantly appears in the other, even when the mirror itself is removed. Entanglement doesn't break physics. It simply shows us that light speed is not the speed of connection.
The universe may hold deeper bonds that move beyond time and space. In the quiet of this moment, let your mind drift to another possibility. The idea that the vacuum of space itself isn't empty. It is a sea of fields, energy fluctuations, and hidden structures. What we call empty space is more like a silent ocean, full of tiny waves that rise and fall, even in total darkness. In some theories, particles can tunnel through barriers faster than light would take to go around them. This quantum tunneling is not a cheat code. It's a reminder that the rules of the universe behave differently at different scales. There are places where the everyday world dissolves and a deeper, softer set of principles emerges. And when researchers observe tunneling, the timing can appear to be faster than light, not because the particle outruns it, but because the particle's presence spreads like a gentle haze, existing in many places at once. Almost like reality itself takes a shortcut, slipping quietly between the lines.
And now, drifting deeper, imagine the universe from a perspective where time moves differently. Not strictly faster, but differently. Gravity shapes time the same way it shapes space. Near a massive object, time slows. Far from gravity, time stretches. If time can stretch and bend, then speed becomes a relative experience. What might feel slower in one frame of reference could feel instant in another. Black holes compress time so intensely that light itself struggles. Yet inside theoretical white holes, or at the edge of hypothetical cosmic strings, space-time could bend in the opposite direction, allowing signals to behave in unexpected ways. These aren't just speculative fantasies. They're ideas supported by equations that whisper about realities we haven't yet touched. The universe may host regions where the fabric of time bends so deeply that what we call speed loses its meaning. In these strange pockets of space-time, the speed of light may be a local rule, not a universal truth. As you drift even more gently into this soft, starlit exploration, imagine that the universe is far larger than the part we can see. Light has only had 13.8 billion years to travel, and while that sounds immense, it's not enough to illuminate everything. Beyond the observable universe, space may continue endlessly, and parts of it may follow different physical laws. Some theories suggest that fundamental constants, including the speed of light, could vary over cosmic distances or eras. Not dramatically, but subtly, like shifts in the tone of a very old song. If that is true, then the universe might host regions where light behaves differently, where energy travels in forms we haven't discovered, or where entirely new particles slip through dimensions we can't perceive. The speed of light might be universal here, in our cosmic neighborhood, but only a chapter in a much larger cosmic story. A story still unfolding, still expanding, still humming softly across the dark. And now, as this gentle journey settles into silence, I hope you feel the calm of drifting among ideas larger than galaxies, carried softly on the endless fabric of space and thought. Thank you for resting here with me and with the Wandering Neuron. May your mind float peacefully and your night be light and quiet. Good night.